Okay, hello people watching this. We are starting with chapter 3 and we are going to the end. We got lots to do. So we got to kind of book. We are starting with implicits. Implicit differentiation. By the way, this packet is what you can use on your test. Also on your test, you may need your unit circle and the, whatever, the derivative.
The little half sheet.
The little half sheet that's laminated, right?
Oh,
yes?
I did.
You might need that guy as well. You put them on the back? Oh, okay, that's fine, that's fine. So, those things you might need for your test. All right, so implicit means x's and y's at the same time. All right, so what's the derivative of x cubed?
3x squared.
3x squared. Okay, what's the derivative of y cubed, or y squared?
2y dy dx.
2y dy dx, okay? And then what about the right side?
5.
No, we have to do the stupid
We have to do the product rule. F prime g plus g prime f. Okay, what's your f part?
F prime is 5x.
Like 5x is your f and y is your g. Okay, so if I'm doing the derivative of f, that is just 5. G is y, so 5y plus what's g prime?
dy dx.
dy dx, okay, or 1 dy dx. And then f is just 5x. Okay, now what do we do?
Combine.
Switch them.
Or like,
gotta kick those guys.
Yeah,
over there.
I want to put all the dy dx's on one side and all the other stuff on the other side. So do you want dy dx's on the left or the right?
The left.
The left. So I need to move this guy over here, and I need to move this guy over here. Yes, it is. Okay. So I have 2y dy dx, and then minus 5x dy dx. Did I do that right?
Yep.
Equals, I'm going to go 5y minus 3x squared if I move him over. Does that work?
And then do you have to like pull out the dy dx?
Yeah, you have to pull out the dy dx. So I'm just going to pretend I've already done that and then divide. Can I do that? Can I do that all in one step? Dy dx equals, thank you, 5y minus 3x squared over 2y minus 5x. Is that confusing? If I pull the dy dx out front, like
No,
that's
it's
what's
okay,
left
I
over, do you see that?
understood.
Yep, so that's what my dy dx is. Ooh, that was a lot of stuff.
Is that it?
That's it.
5y minus.
I actually like this method.
5y minus 3x squared over 2y minus 5x. Yay, beautiful. Okay, that was the first one. Good? Moving on. Holler at me if I'm going too fast.
Are you recording this?
I am recording this.
Good.
But we've only done one problem, so jump in. We're on 28 now. Find the slope of the tangent line. That means
Y equals mx.
derivative. We don't need to do the whole y equals mx plus b, just the m part, just the slope. And the point that I'm plugging in is 10(3), but I'm plugging that in after I find the derivative. Okay? So let's do the derivative of y squared.
2y dy dx.
2y dy dx. Okay? Minus the derivative of x is
Minus
1. The derivative of 1 is
0.
gone, and I have him equal to 0. Okay? Alright, now what do I do?
Plug in. Or no, you have to divide the.
Let's solve for dy dx. So I'm gonna kick
How'd
the
you do
1 to
that?
the other side. Whoop, thank you. Oh gosh, you're awesome. Okay.
I didn't know if I was gonna blow up my grip.
No, you don't.
I just put
Yeah,
You
this,
don't.
and he smells.
Yeah,
He's
he
got like a
He's
he's
got
got like a lavender smell to it.
Did I give you that one, the tiny cow one?
Yeah.
One of the mummies?
Yeah. I have a tiny cow. and a
I've
big
always
cow.
wanted one. I
Yeah.
never did get one.
He's
love
awesome. My kids have like
I just used it as a
4
stuffed
of
animal.
them apiece. It's crazy.
I should
Alright, I'm
have
gonna add the 1 over, and then I'm gonna divide by 2y. Can I do that?
Yep.
dy dx equals, that would be 1 over 2y, yeah? Okay, so I need to do what now?
Okay.
Plug in. What am I plugging in?
There's a 3.
3.
Yeah, I don't have an x coordinate left over, so I don't even need the 10, I just need the 3. So dy dx will be 1 over 2 times 3, which is 1/6. That's what my dy dx is. Perfect.
Sounds good.
Okay? And that's all I need. That is the slope of the tangent line. Now, if I say the equation of the tangent line, that's the m, and I would have to find the b value, right? Okay?
Right.
But I'm not going to do that, because we only have to find the slope.
Find the derivative.
Okay? Alright, the next one is an ln.
Okay.
Do you remember
No.
Do
You
you remember
prime
the
over
derivative
you.
of ln? I'm just going to write the rule.
You prime over you.
ln of u is equal to,
Oh, yeah.
really 1 over u times u prime, but a lot of times we do just u prime over u. We lump him, we like shove him to the top, right? Okay?
Okay.
So that's my my equation for derivative of ln.
Third plus 3.
So it's like 1 over, oh wait, Yeah,
times
4x to the third
12x squared
plus 3x minus 7, and then times, you
which
said
is
12x squared plus 3?
12x squared plus 3 over 4x
Yeah.
third plus 3x minus 7.
That's a 3 plus 3x. I'm trying to keep up with you, Jose, and you're going too fast. Perfect. There you go.
See, that's how
There's
it
my
was the
derivative.
past 2 days. Always just like.
There's my derivative. Now, a lot of you guys go straight to that, equate to that, and you don't do the middle step because you're like, why do that? But that's, yeah, if you're ever confused, that's why. I read all the steps, okay? Okay, good?
Yeah.
Pause. Okay, all right, you have to holler. I'm more than happy to pause, but you gotta yell at me.
We're trying to yell at you through the video. You didn't.
Yeah.
I know. Oh, when I made mistakes, and then I went back and fixed it, I was like, somebody's yelling at me right
No,
now.
it was
I
the
know.
graphs. Because we were like.
It was what?
Graphs, and we were all laughing.
Oh, yeah.
So.
Yeah, and then I caught it later. But then there was another thing that I
Why
did.
didn't you guys tell me?
Yeah, literally. Why didn't you guys tell me? Why are you?
There was another thing that I made a mistake on,
Yeah,
wasn't
you
it?
did. Yeah,
Was
but
that
you
in
went
this
back
class?
and- Yeah, it was like you didn't do the n minus 1 for the derivative. You just.
Oh
left the one
yeah,
half.
I left
And
yep.
trig-
I left it
And
as one half.
I was confused. I was sitting here like, what?
Yep, and then I caught myself. Is there anything I didn't catch myself
There
on?
was something in trig. You didn't flip the sign when you divided by a negative. In trig.
Oh yeah, but then I did later, right?
Yeah.
Okay, cool. All right,
And you're
so
like, why didn't you tell me?
yeah, why didn't you tell me? Okay,
Trying to.
and you guys were yelling at me the whole time, right?
Yeah.
Okay, so 30, use log differentiation. That means you're ln-ing both sides. And you are more than welcome to, I wouldn't, but you're more than welcome to do this guy without ln-ing both sides, but that would require me to do the quotient rule, right? And within the quotient rule, I have not just one chain rule, but 2 chain rules.
Yeah, we're good.
Right?
Right.
So we do ln's instead, right? We ln both sides, okay? So on my left side I have ln of y equals. Now I break that apart, and this guy is ln of the square root of x minus 4
So 1/2.
minus ln of x plus 6 to the third power. Now the deal is, this guy's to the 1/2 power, right? That's what the square root means, but then I can bump the 1/2 down in front. So I have 1/2 ln of x minus 4. No, he's just positive 1/2.
Oh,
Yeah. ln y, and then minus, I can bump the 3 down in front, so this is 3 ln of x plus 6. Alright, and now he's broken apart, and now I can do my derivatives finally, right? What's the derivative of ln of y?
1 over y dy dx.
1 over y dy dx. Equals, okay, the 1/2 is just gonna chill. What's the derivative of ln of x plus 4, x minus 4?
It's 1 over 2 times.
1 over x minus 4 times 1, really, right? I'm gonna simplify him. You guys can skip steps. Yeah. Minus 3 times the derivative of ln of x plus 6 is 1 over x plus 6 times the derivative of x plus 6, which is 1. Okay? Alright?
I just combine.
You just combine all you want. Okay, I'm just writing out all my work. So this guy is 1 over 2x minus 8. Did you do that route?
Yeah.
Minus,
Are we leaving y or are we plugging y back in?
you can leave y if you want. Okay, there's that, right? Like the 3 goes on the top. That's what he is. Okay, now I'm going to bump this y to the other side, so we've got to multiply by y. So y times all that junk, so I'm going to do y times that stuff. And that's what dy dx is. Very good. Whoop. Good?
Yep.
Does that make sense? If it doesn't make sense, you holler at me. Is there anything else that didn't make sense on any other ones that you started and you're like, I have no idea how to do that?
No.
Like, what did she do? Okay. All right, so there's that one. Let's go to 31. 31, how do I find the derivative of this?
Or product. Or ln. Product,
I mean, you could, let's just do the product rule. Okay? What's the derivative of y?
dy dx.
dy dx. Okay, so we'll call it dy dx. Equals, I do the product rule. So the f part is this guy, this is f, and this guy is g. Okay, so I do f prime g plus g prime f. By the way, how do you take the derivative of a e? So e to the u, what's the derivative of e to the u?
E to the u.
E to the u
Times u prime.
times u prime, and I usually put the u prime in the front, right? Okay, so he stays e to the u, but then you take the derivative of the exponent and he comes down in front, okay? So if I'm doing f prime, what's the derivative of x to the 4th power? 4x to the 3rd, he is there, and then g just stays e to the 5x, okay, plus g prime. I want e to the 5x,
So
the derivative of that.
5x.
Yeah, e to the 5x stays, but then I have to take him times the derivative of 5x, which is just 5. Yep, that's what my g prime will be, and then x to the 4th. Okay,
How do you
I'm just gonna, yeah, there's not really a whole lot to do, but drop the parentheses. So I'm gonna go 4x cubed e to the 5x, can I just write him like that, without parentheses? Plus,
you put x to the 4th in the front?
I'm gonna go 5x to the 4th like that, I'm gonna do him like that. E to the 5x.
5x to the 4th?
Yeah, like there's a 5 in front, and then the x to the 4th I'm gonna do like in that route, does that make sense?
Got it, so the 5 isn't like
And that's
attached
it?
to E?
No, because they're all being multiplied together, so I can put them in any order I want to. Yeah, and I can't put those together, so that is it. That's my derivative, using the product rule. Derivative using the
Like
product rule.
30-ish, no, 20-ish minutes.
What? We have 20-ish minutes left?
Yeah.
Left? Oh, okay. Oh, how much do we have left?
problems.
We got 40.
You
Oh,
just
okay.
can like move for one day.
Okay,
Just
alright.
go till the bell rings.
Okay, find the derivative. This is the inverse sign. How do you find the what's the rule for inverse sign?
No idea.
Inverse sign of
You
u
ready?
is, give it to me. What do you
U
got?
prime over the square
Are we
root
gonna
of
need
1
to know
minus u
We have our
squared.
paper.
And that's it?
Yep.
Yeah.
Hey, there you go. Okay. What is u in this case? What's u?
U is x
Squared plus
yeah.
8.
Okay, that's what u is. Alright, so I want u prime. U prime goes on the top. What's u prime?
2x.
2x, okay? The square root of 1 minus u squared, which is x squared plus 8 squared. And that's all. That's all. We're not gonna FOIL it out.
Wait,
We're not gonna do anything
hang
else.
on. Wait, whoa, I missed something here. Okay, sine -1 to the u.
Yeah, this rule is on that laminated sheet, so make sure you have that laminated sheet with you. Because maybe I'll ask for like cosine instead, right?
Mean.
So make sure you know what those are. Got it?
Mean.
Did we get our packet on our test?
Yes. You get your packet, you get your unit circle, you get that laminated sheet that has derivatives on it.
Were you supposed to turn this in?
Thank you.
Luke, I figured it out, or Mrs. Comancher figured it out.
Perfect.
Did you count those cans, Luke?
Did we make it?
Yes.
Yeah, we're at like 2,000.
You're at like 397
Oh, here it is.
last count.
Pretty short.
Wait, what? On the board it says 2025.
Were we just supposed to use the
That's the
3?
year.
Yeah, this is the year, and that's his.
Somebody just wrote it on there?
Because it's less than 3.
Okay,
But I won't be here Monday.
33. We better get booking.
Gotcha.
33 is a related rate. 33 is a related rate problem. So if you are one of those people that you're like, I need to do this,
Girl, you barely gave us
Equation?
any room.
I know. Equation, no, find. Or just do it like this.
I hate these.
I'm gonna do my equation here. I'm gonna do my no here. I'm gonna do my find here.
Can we skip these on the test?
If that wants to be your skip one, that's fine.
Jalen, don't skip anything.
I can't.
Okay.
Wait, the related ones are
Alright, what I haven't even read anything, but what's my equation?
easier than product.
Surface area.
Hey, surface area equals 6s squared. We're doing surface area of a cube. Okay? Alright, so I'm giving you, I already gave you the equation. Alright, let's figure out what we know and what we're trying to find. Alright, so the edges of a cube are expanding. What did I call the edges? S, and the edges are expanding at a rate. So we know ds dt, right? They're expanding at a rate of 6 centimeters per second. Great. How fast is the surface area changing? What are you trying to find?
The surface
The surface area, how fast it's changing. So ds dt, not just the surface area, but ds dt. Okay? I'm trying to find the rate of change of surface area. When each edge is 5 centimeters.
So when S
When s equals 5. That's another no thing. Okay? Alright, so what do we do now? Derivative.
So dSA dt
ds dt, yep.
is equal to 12.
12 S,
That's it.
nope,
DSDT.
Oh, yeah.
DSDT. Yep, DSDT.
So then.
Okay,
And then
that's my
five.
derivative. Now I plug stuff in. Okay,
6.
so DSADT is equal to 12 times 5
360.
times 6 is what?
360.
360 what? What is surface area labeled as?
Centimeters cubed.
Centimeters
Squared.
squared per
Per
time
second.
second. There you go. That's the rate of change of the surface area. It's expanding that much.
Oh no, not equal.
Okay?
I like those are the easiest
L'Hopital's
ones, though.
rule. Yeah, 2 L'Hopital's rule. So first we have to find which indeterminate form it is. Which indeterminate form,
0
okay?
to 0.
So that means I plug it in to begin with, and let's figure out what he's doing, okay? So what's 5 times 0?
0.
0. What's sine of 0?
0.
0. So the indeterminate form is 0 over 0. Okay, so how do I correct it?
5 over cosine of x.
Yeah, you take the derivative of the top and the derivative of the bottom.
5 over 1.
Okay, my derivative of the top. This is where I don't use the quotient rule. If I was just to take the derivative of this, I would be using the quotient rule, but you don't have to use the quotient rule. You just take the derivative of the top and derivative of the bottom. Derivative of 5x is 5. The derivative of sine is cosine. By the way, did I do my derivatives correct yesterday?
Yeah.
Yeah? Okay. I was just like going off of what was in my head. Alright, now if I plug 0 in, 5 over cosine of 0. What's cosine of 0?
1.
1. So I have 5 over 1, which is
5.
5. That's what the limit is. So he was an indeterminate form. We couldn't figure him out before, but now we take the derivative and he's 5. Good. Okay, 35.
Infinity.
Which indeterminate form? If I take 2 times infinity, I'm going to get a really big number, which is infinity. If I take infinity plus 7, it's going to be another infinity. This is my indeterminate form. We can't determine it from there. But what I can do is I can take the derivative of the top and the derivative of the bottom. Not the quotient rule, but just the derivative. What's the derivative of 2x? 2. What's the derivative of x plus 7? 1. And now I don't even have to plug anything in because the derivative's already 2. By the way, when you're finding a limit at infinity, it's kind of like finding the ha. N is 1, m is 1, which means I look at my leading coefficients, which are 2 over 1, which is 2. Yeah? Trick kids, maybe that is ringing a bell for you guys. Anyway, 2 is the answer. Good, good. Okay, find the vertical and horizontal asymptotes. How do you find a vertical asymptote?
Bottom.
You said the denominator equal to 0. Let's do that real quick. The denominator, x minus 4 equals 0, so x equals 4. That's my VA. Okay?
And N and M.
For a ha, you look at n and m. N equals, m equals. N is the degree of the numerator. M is the degree of the denominator. Okay? So what is n in this case? 1. M is also 1. Okay? If n is less than m, if n is greater than m, if n is equal to m. If n equals m, you look for the leading coefficient over the leading coefficient, which is what I'm doing in this case, but let's write the other ones down. So if n is less than m, that means he's bottom heavy, which means he's going to
All over.
sit. He's going to sit at 0. If y is greater, or if the top is greater than the bottom, that means he's going to fall over and he's not going to have a ha. Okay?
Is it none or does not exist?
Both.
If they're asking for a ha, then that would mean he would not have a ha. But if you're finding the limit, which is kind of like finding the ha, then that means the limit does not exist. Right? That makes sense? Okay. So here we have y equals, what's the leading coefficient at the top? 2. 2, leading coefficient at the bottom? 1, so y equals 2 is my ha. Ha, ha, ha. Here we go. Happy with that?
That was really ugly.
Oh, we're done.
No, we're not.
We're not what?
We got 4 left.
I thought we were gonna be on at chapter 4.
When are we going to do chapter 4?
Why would we not do chapter 4?
Oh wait, it's Friday.
It's Friday. We have, we're like, this is it. This is our last day. Find critical numbers and only find the critical numbers, okay? When I say critical numbers, I mean like your first derivative critical numbers, okay? So we're going to take the first derivative. G prime of x. What do I have to use to find the derivative of that thing? Chain rule. Okay, so that means the 3 comes down in front.
3x squared
X plus 1 stays, and now he is to the second power
times 1.
times 1, because that's the derivative of the inside. Now what do I do with that?
Plug in. Nope.
Set that equal to 0.
Set that equal to 0. So 0 equals, I'm gonna like just multiply the 1 by the 3. So I've just got this guy. Alright, now I'm solving for x, right? What shall we do?
Get rid of the 3.
Divide by 3. What's 0 divided by 3? 0 equals x plus 1 squared. Then what?
Square root.
Take the square root. What's the square root of 0?
0.
0,
Couldn't we just
x plus 1, and x equals,
Set that from that.
what's
And
that?
we have to find the derivative.
What?
I mean, it worked for that one.
But that won't always be the case. Yes, so you have to find the derivative. Yep. So that was a nice coincidence in this case, but. So I have one critical number and he is -1. Cool. Oh, look at that.
Okay, so
Next.
we got negative infinity to
38 says, okay, if that is my critical number, find where he's increasing or decreasing. So how many test intervals am I gonna have?
2.
2.
2. I gave you a really wide box, but you only need 2 test
Thank
intervals. He's
you.
going from negative infinity to
-1.
-1, then from -1 to infinity. Okay, let's figure out what's our test point gonna be. I didn't give you a column for that.
-2.
Let's test -2. Okay, and then what are you gonna test on the right side?
0.
0? Cool, let's do it. So where are we plugging into, by the way?
The derivative.
To the derivative, and the derivative is 3 times x plus 1 squared. Okay, alright.
-2 plus 1 is -1.
-2 plus 1 is -1,
That's
-1 squared is
3.
1 times 3 is
They're both 3.
positive. So he is increasing, right? If I plug 0 in, I'm gonna get
0.
0 plus 1 is
1.
1. 1 squared is 1 times 3. That's a positive again. So he's in. How is he increasing in 2 places?
Concavity. It goes.
So this guy's parent function is to the 3rd power. Do you know what to the 3rd power looks like?
It looks like.
Right? So is this gonna be a max or a min?
No.
No. He's increasing on both sides. So this is actually neither a max or a min. They were just asking for determine the intervals upon which he is increasing and where he is decreasing. So where is he increasing?
Everywhere.
Everywhere. So you can say all reals, or we can go negative infinity to infinity. Where's he decreasing?
Nowhere.
He's not.
What?
He's not decreasing anywhere. Which means this guy is not a max or a min. He's probably a poi. He is a poi. Because I know what x cubed looks like. Alright, next. 39. Find the relative extrema.
Yeah.
That means maxes and mins. Max / min. Okay. How do I do that? First,
3 to the 3rd.
yeah, 1/4 times 4 is just 1. So this is t to the 3rd minus
8.
8. Cool. Now what?
Plus
That's
or
my
minus
derivative.
2. Yay.
Equals
0.
0. Then I add the 8 over, so t cubed equals 8. And then I take the cubic
2.
root.
T equals 2.
You're close. Oh wait,
Plus and minus 2.
wait,
No, it's
wait.
the
Is it
cube.
plus and minus 2?
No, because it's.
It's
No.
cubic root. So it's only 2. T equals 2. That's it. So I still only have 2 test intervals. Going from negative infinity to 2. And from 2 to infinity. Okay. Alright, what point would you like to test?
1.
0.
Let's go 0. You could do 1. It doesn't matter. What do you want on the right side?
3.
3. Okay. And I'm plugging those into the
Derivative.
t cubed minus 8. Okay. If I plug 0 in, what's 0
Negative.
cubed minus 8?
-8.
Negative. Okay. If I plug 3 in, 3 cubed minus 8.
Positive.
It's gonna be positive. So he's decreasing and then he's increasing, which means he's going down and then he's going back up. So what's this point right here? A min. I have a min at where?
We plug it in.
At 2 comma something, right? Because that's
Yeah.
where my point switches. Okay, how do I figure out the
Plug
something?
it back into the.
Plug it back in. So I have
1/4.
1/4 times 2 to the 4th minus 8 times 2. 2 to the 4th power is 16. What's a fourth of 16?
4.
4 minus
16.
16, which is negative 12. So I have a min at 2 negative 12. Cool.
That was lots of math.
That was lots of math. That was a lot. And that was really fast.
Okay.
No loss.
Next one.
Uno más, one more.
Mm-hmm.
Now I'm just trying to figure out concave up, concave down.
Oh, I missed
So
it.
I do not care
Here.
about increasing, decreasing. So what's that mean?
We just need the second derivative.
I just need the second derivative, okay? So let's do the first derivative. F prime of x equals, what's my first derivative?
Negative 3x squared
Okay, plus,
12x
uh-huh,
minus
minus
9.
9. Okay, now, if I were doing increasing, decreasing, I would stop and find my critical numbers and all that good stuff, but I don't care about that. I want just concavity,
So negative
So,
6x
uh-huh,
plus
plus
12.
12. Okay, now what?
Set it equal to 0.
Set it equal to 0, okay? Alright, so I'm gonna subtract the 12 over, sure.
So that
Negative
says
6x
negative 2.
equals negative 12, and then x equals
Negative 2.
positive 2.
Positive 2.
X equals positive 2, okay? So, how many test intervals?
2.
2. We don't know why I give you such big boxes. Whatever.
So negative infinity
0 and 3.
2.
To 2. And 2 to infinity. 2 to infinity. So she wants to do 0 and 3 again?
Yeah.
Okay, and where are we plugging into? The second derivative, negative 6x plus 12.
Wait,
Okay,
so it just when it's concave up, concave down, you do the second derivative
yes,
instead of the.
yes. It's basically like saying find increasing, decreasing, but for the second derivative.
Are we gonna have to do
Yep.
both in any problems, or is it just like this?
It'll just be like this. Yep, yep. I just don't want to overload you with one problem. So, because if you screw up the first derivative and that stuff, then you know, whatever. So, all right, if I plug 0 in, 6 times 0 plus 12?
12.
Plus, so yeah, 12. If I plug in 3, negative 6 times 3 plus 12 is negative. So, that means for the first interval, he is concave
Concave down.
up. He's
What?
concave up.
Positive.
But
you
you
said
said
plus.
he was opposite.
No, that is when you are plugging into the, yeah, that's the second derivative test, which I'm not going to make you do.
What isn't
That's
this the
like,
second derivative?
he's a minimum if it's plus, he's a maximum if it's minus. That's different. He's concave down here. Okay, so it says list the intervals. So he's concave up and he's concave down. So where is he concave up?
Negative 2 to infinity.
Negative infinity to 2. He is concave down from
2 to negative 2. Or 2 to positive
2 to infinity. There we go. That's all my stuff. Okay,
Hallelujah.
happy with that?
Yep. Sure.
Wonderful, wonderful.
Okay. I need to do this one.
Tommy, I didn't
Okay.
have all of those
All right.
written down.
Go by whoever's watching this.